We have solved equations with fractions like the first example and an example already. So we're going to take those skills and expand them to some harder questions. So who can tell me how I do that first one? Adam. Very nice. So the answer is going to be 10, very nice. What number divided by 5 is 2? 10 divided by 5 gives you 2. But like Adam said, you're going to multiply by 5 on the other side. Why? Because remember, really what we're doing here is so x over, I'm just going to rewrite this so I have some room. Whatever I do to one side of an equation, I have to do the same to the other. So if I multiply both sides by 5, then those ones divide, which maybe seems weird to people because it looks like you're dividing the x by 5. Now all of a sudden I'm dividing the 5 by 5, but that's math. That's fine. You're allowed to do that. So 5 divided by 5 is 1. So now I'm left with 1x, or x, equals 2 times 5, which is 10. So I looked at the denominator, which was 5, and I multiplied by that. And it got rid of it. Notice after we multiply by 5, there's no fraction left in the question. So that's like a one step. There's only one fraction in it, and there's only one other thing in the whole equation, so it's not too complicated. But what we need to recognize is you can always multiply by denominators in equations only, not other things, but in equations. Multiply by the denominator to get rid of fractions. People hate fractions, famously, right? They're like, everybody hates fractions in math class. But I actually say in an equation, fractions are no big deal because it's one step. You multiply it by all the denominators. If you have more than one, you multiply by all of them. It gets rid of the denominators and no more fractions. It's actually not that hard. So that's what we're going to work on today with some simpler questions. Tomorrow we'll move on to some harder ones. So this one looks kind of like a proportion. And again, the way that we typically solved proportions was what would we do? Brianna? Possibly something like that, but there was a different way that I taught. People do it a different way. Thomas? She said something about denominators. What were you thinking? Well, can you tell me exactly what you were going to say? Okay, good. Summer? Cross multiply, that's what people like to do, but remember I said, I don't love that word, I don't love that term. Yeah, that's how I like to do it. Just multiply by the 3. This is a little bit tricky, but in this case, because it's like a proportion, x over something equals just a fraction, you can multiply by just the denominator. Okay? And that's going to clear it. Now, I'm going to show you something though. When people say cross multiply, this is what they're actually doing. They're multiplying both sides by both denominators. You might not think that's what you're doing, but that's actually what you're doing. Okay, put your pencil down for a second and watch, and your phone for sure. Okay, these two are going to divide to 1. So now I'm only multiplying, the 3's gone, and I'm multiplying the left side by 6. And these two divide to 1, and I'm multiplying. See how that is what you're actually doing when you cross multiply? I'll multiply the right by 3, and it disappears on the left, and I multiply the left by 6, and it disappears on the right. Like this is what cross multiplying actually is. And that's why I worry about calling it cross multiplication, because that's not really what it is. But anyway, okay, so if I do this, I end up with 6 times x, which is 6x, and 5 times 3, which is 15. But now I just have to go back and divide by 6 on both sides. Again, this is why I don't really see the point, because it's extra work. And what's 15 divided by 6? Let's do a decimal answer here, 2.5. If you left it as a fraction or left it in this case as a decimal, either one's fine for today. So a couple of things, not to confuse anybody. So I hope this isn't confusing. If you were good at doing proportions without like that cross multiplying thing, then keep doing that. Just multiply by 3. That's what I would recommend. But this idea of multiplying by both is very useful when we get to harder questions, kind of like this one. So let's try this one. Again, there's a couple of different ways you could do it, but we're gonna do it like the fraction way to help us, like a particular way to help us today. If I didn't have this 1, what would I do? Ethan? Yeah, and so tell me exactly. Yeah, I'm going to multiply both sides by 4. Exactly. Well, guess what? Just because there's a 1 there, I'm still going to do that. So this is what I mean about fractions. You look at the denominator, you multiply everything by that, and the denominator's gone. So that's what we're doing today. So watch how it looks, because it's going to look a little bit different when you have more than sort of one thing going on. I'm going to multiply this by 4. I'm going to multiply this by 4. And I'm going to multiply this by 4. So if I look at A, there's 2 things, x over 5 and 2. So I multiply both of them by 4. You got to watch here, folks. You got to watch. Because this is something that people don't understand because they miss it, and then you can't, and it doesn't work. And you won't figure this out on your own. This one has 3 things. So I multiply each of them by 4. See how that's different? People would miss this one. They wouldn't multiply the 1 by 4. Okay, so again, just watch what's going to happen. These divide to 1. And that leaves me with x. What's 4 times 1? 4. What's 4 times 5? 20. How do I solve this? Sorry? Yeah, so subtract 4 from both sides, and I end up subtracting 4 on the right. Very nice. And x is 16. Yeah. Probably. Yes. Yeah, show me after, but yes, I think so. As long as the 4 gets multiplied by every one of those things. I'll take a look at what you mean exactly. Okay, let's try a couple of different ones. This one's a little bit trickier again. Jake, what do you think is different about this one? Variables on both sides, that's one of the things. Very good. What else? Adam, what do you think is different about this one? Nice. So there's variables on both sides, there's fractions on both sides. What do you notice about those fractions? They both have A's. Good. Ethan? Nice. They have different denominators. So this is a different kind of question where you have multiple fractions with different denominators. So I would just put my pencil down for a second and watch. I'm going to multiply everything in here by all the denominators. So I'm going to multiply by 2 and by 3, a over 2, plus multiply by 2 and by 3, 3, equals multiply by 2 and by 3, a over 3. So see how the question is still in there. A over 2 plus 3 equals a over 3. Those look like 9s. And all I've done is multiply the left side and the right side by 2 and by 3. That's the same as multiplying by 6, but I grouped it this way so I can do this. Watch. 2 divided by 2, gone. 3, nope, sorry, that one doesn't happen. That's not dividing by anything. 3 divided by 3, gone. And this ends up being 3 times a plus 2 times 3. You don't have to write this out. You could do the math. I'm just trying to illustrate what's happening. So this is 3a plus 2 times 3 is 6 times 3 is 18 equals 2a. Now, how do I solve a question like this? No, do you remember? Yep, and? Which would you like to do? Okay, let's move the 3a. I'll do that by subtracting 3a from both sides. And I get 18 equals, what's 2 minus 3? It's negative 1. And then divide both sides by negative 1. And negative 18 equals a. You okay with that? Yep. Okay. Watch. So we'd be starting right here. 3a plus 18 equals 2a. I'd have to move the 18 and move the 2a. And 3a minus 2a is 1a. Those are gone, and I'm just left with negative 18 on the right. Same thing, just a different way of getting there. Okay, let's try this one. It's very similar. So what are you going to do? What do you think? What are you going to do? Josh, have any ideas? Same idea, Kevin?
Yes, you're going to times everything by 3 and 2.
Nice. So let's do it. So if you want to know what that looks like, you can watch. So times 3 and times 2, because those are my denominators, right? And then multiply that by x over 3 equals, multiply this by 3 and by 2, and that's x over 2 plus, and multiply the 5 by 3 and by 2. This is the part that people forget. And again, watch. 3 divided by 3 is 1, they're gone. 2 divided by 2 is 1, they're gone. So I'm left with 2 times x, which is 2x. 3 times x, which is 3x. And then 3 times 2 is 6 times 5 is 30. Okay, and then hopefully this part, we did a lot of this early on, so if you don't quite remember how to do it, it should come back to you. Divide by negative 1, divide by negative 1. X is negative 30. Okay, one more example that's a little bit trickier again. So what would I do in this case? Kenzie, what do you think? Very nice. See how easy this is? Look at all the denominators and multiply everything by that. Now you think there's 3 of them, so this is a lot of writing, and the first line is going to be kind of long, but that's okay. You don't have to copy this down if you don't want. Watch me do it, though. Please don't go on your phone. Your phone should still be put away. Watch. I'm going to do it 2 ways. So I'm going to do it fast to try to get through it. Okay? So the first way I'm going to do it like we've been doing. So it's going to be 2 times 4 times 8 times x over 2 plus 2 times 4 times 8 times x over 4 equals 2 times 4 times 8 times 3 over 8. So the 8s are gone there, the 4s are gone there, and the 2s are gone there. And I get 4 times 8, which is 32, so 32x. 2 times 8, which is 16, so 16x. And 2 times 4, which is 8 times 3, which is 24. Okay, and then I would add them together and just work out the rest of it. There's another way that you could do it, though. This way is awesome. It always works. It's easy for some other stuff we're going to do down the road. It's a really good system. So if you like it, go with it. If I'm going to do one more example, like I'm going to do this example again and show you another way of doing it that for some of you you might like, but it only works in certain cases. It's only helpful once in a while. When I look at 2 and 4 and 8, there's something in common in all of them. That they all divide into 8 evenly, right? 8 divided by 2, 8 divided by 4, and 8 divided by 8. So it's kind of like if you were finding a common denominator, the common denominator would be 8. This is going to look shorter, and some people are going to think, oh, why don't we just do that? Well, it requires a little bit more understanding of this stuff. So it's not for everybody. But I could also have just multiplied everything by 8 instead of by all 3 of those things, and watch how it works out. But again, it's a little bit different. 8 times x over 2 plus 8 times x over 4 equals 8 times 3 over 8. Okay, so these guys are gone. Here's where it's trickier. I have to do 8 divided by 4 gives me 2. It doesn't just go away. There's something left. 8 divided by 2 gives me 4. And what do I do with those little green numbers? 4 times x is 4x plus 2x equals 3. In this case, it seems maybe shorter, but that step of multiplying by 8 with the 2 on the bottom and getting 4, that's something a lot of people never quite click with. So to avoid that, you do it this way, and this way always works. Not right now. Any other questions about math? Okay, so here's what we're going to do. We're going to do question 1. Do every other of those. You don't have to do every single one. And then you're going to jump to question 3 and 4. And those are the ones that we really want to practice because they're the trickier ones. I'm going to put it up here for a second, but then I'm going to put it up on the classroom and you can access it there.